Okay, so moving on, we'll look at making it real now. In the first video, we saw the foundations of AI and how LLMs work, and we built a simple RAG pipeline. In this, we will look at actual chunking strategies and identify the one which works the best for us. We'll look at Pinecone as a vector DB and how we can use it in our application. We'll look at building conversation memory, which is helpful in applications similar to chatbots. And we'll look at getting structured outputs from LLMs, on top of which we can build our application. Now, chunking strategy, which is the first part, is the most important decision that you would take for any application. In the previous video, I took 500 characters as an arbitrary number, and honestly, that's a problem because if the chunk size is too small, and here are a couple of examples. If the chunk size is too small, for example, let's say click the export button in the top right corner, it doesn't capture the information like which page format or permissions is it needed. And while a user who has asked a query on exporting options, this sentence might be picked up as a chunk, the LLM will hallucinate on top of it and give you a response which may not be true. So that's a problem with small chunk sizes. On the other hand, if you have longer or larger chunk sizes, which could be entire pages, the relevant sentence or the response which the user is expecting or the customer is expecting is buried inside this large piece of text. So the model could find the wrong answer, and also it might take a longer time to process. Now, to overcome this, we have to find the right chunk size and the right chunking strategy. So at the bottom, you can see there are three ways of doing this. The first one is something that we already saw, and this is the very basic level of chunking, and it works for unstructured documents where, let's say, it's a large essay or large, maybe a novel or a book written for something. You could use it for that. Probably not the best way to use chunking on articles, especially help articles. Second is sentence based, which splits chunks into natural sentence boundaries. So you would not have half sentences in any of the chunks. And it is better for long form documents where answers could be across several paragraphs. And third is the section based splitting or chunking, which takes a document and splits them in sections which are self-contained and might have answers or some relevant information in each section. And we will see how we identify and create those chunks. Now here we can see the three strategies for chunking. The first one is the fixed size chunk, which we have already seen where a chunk size is, let's say 500 and we have an overlap of 50. Second is a sentence-based chunking, which splits the text into sentences and groups 5 sentences together as one chunk, which is also relatively straightforward. And the third one is section-based chunking, where the separator or something that splits text into chunks is two new lines, as we can see here. So I'm just going to run this on all these three strategies on the documents that we have. And here we are just going to print out and see how many chunks are getting generated for each. Let me just run this. Okay, so we got the results here. We have the number of chunks for each strategy. The first one with the fixed 500 characters, we have 109 chunks. The second strategy gave us 95 chunks where 5 sentences are grouped together. The third one gave us 147 chunks. That's the highest number of chunks that we have among all these three strategies. So this is already interesting. Now we'll look at putting all of these chunking strategies into our RAG pipeline and see if they're able to answer the questions that we have for them. So now I have the RAG pipeline that we built in the first video open here, and we have this new file where we have listed down all the three chunking strategies at one place. What I'm going to do now is to test this. I'm just going to take this chunking function, add it to my RAG pipeline, and we will run this for a specific question that we have. So we have the entire pipeline here with retrieval and generation as well. We are just going to ask it one question: how do I export my project data as CSV? And I'm going to run it. And what this will do is it is going to chunk the data, which is usually pretty fast. Then it is going to do the embedding, which will again take a few seconds. Now, as you can see, the embeddings are ready, and the retrieval is also done. We have received 3 chunks of data or embeddings, all of them coming from the same document, ClearDesk FAQ text. And we have received these 3 chunks. Some of them you can see don't have complete sentences. And obviously the function that we have here, the script that we have here, sends these to AI and then we get a response. So this is a response that we have received, that to export your data or project data, follow these steps. Open the project, you want to export 3 dots, right on the top right corner and select export, choose CSV. You can export all tasks and so on and click generate export. Download should start in 30 seconds. And it has given me note your editor permission or above is needed. These permissions are needed. Guests cannot export data. Now, just to cross check with our actual FAQ data, do we have the same answer? So here, yes, as you can see, we have the same answer here where it says open the project you want to export. Click the 3 dot menu on the top right corner and so on, CSV format options. And if you notice, the answer is pretty much the same. It also goes on to say that guests cannot export. For large projects, the export is sent to your email. So all of this information is covered in the answer. Now, as you can see, the current format of chunking is able to give us this answer. We'll still check with a couple of other questions and see if this works for other use cases as well. Now we will try asking it another question. In this, I'm not going to ask a question where the answer is given in the FAQs directly. I will expect the embeddings to have this answer somewhere, um, and the LLMs to think why the user is facing this issue. Although the answer is somewhere embedded in these documents, it is not given as a straightforward FAQ. So let me run this and let's see what response do we get. So we have received the response now. Here, as you can see, it is saying that it seems that you might have reached the limit of active projects allowed on your current plan. On the starter plan, you can have 10 active projects. On Pro plan, up to 100 and so on. And if this doesn't answer your query, then let me know and I can escalate for further assistance. So this is the answer which the LLM has given through the embeddings. And if I go to this plans and if I actually search through these plans, if this information is correct, you will notice that yes, you are able to see whatever is mentioned here in this as well. For example, if I look for active projects, the starter plan has 10 active projects. Let me just search for it, active projects. The Pro plan has 100 projects, and this seems like a decent answer which it has given with our first chunking strategy itself. So it seems to be working for now. We are also going to now test the other 2 strategies with the same 2 questions that we have. So let us go back to the second strategy. I'm just going to copy the code for chunking, and I'm going to replace our existing chunking function with the second strategy for chunking. Okay, I'll clear this and I will run it. Okay, this requires importing a library, which I've done now. It should work. Yeah, so the chunking has started. Again, since we are redoing the entire chunking process and embedding, this is going to take a few seconds. But as you can see, the chunk size has gone down from 109 to 95 chunks. Okay, so now you can see that it has given us the answer for the second question that we had asked. And it says if you're unable to add another project, it might be because you've reached the limit of active projects allowed on your current plan. On the starter plan, you can have 10, on Pro plan 100, and so on. You need to archive existing projects and so on. So again, this seems to be the correct answer. What we are going to do is we are going to ask the first question to this chunking strategy as well, and we'll see how the response comes out. Now we have received the second answer as well, or the answer to the first question in this case. And if you see, the answer is very similar to the first chunking strategy. So it is just two questions, but for now I can see both the chunking strategies are working in our particular use cases that we have. Now we'll just try out the third chunking strategy and see if that makes any difference. So I'm just going to take this and add it to our RAG pipeline. And again, I'm going to clear this and rerun the chunking and embedding parts. In this case, we have 147 chunks, and the example chunk, as you can see, is slightly different from what we had seen earlier. Okay, now we can see that the embeddings are done, and we have received the answer this time to the first question in the first go in this third strategy. As we can see, the answer is pretty much the same. You will notice this is happening largely because our input documents are fairly well structured, um, and all these three strategies seem to be working. Uh, in an actual real world scenario, you would have, let's say, the most common 15, 20, maybe 30, 40, 100 questions that you would test all these strategies for. And the ones that give you the best answers for all of the questions that you have or the common queries that users have, that's a strategy that you would select. In our case, all the three seem to be working and giving us fairly good results. So we can go with either of them. Now we'll look at the next part, which is vector databases. So until now, if you would have noticed, all our embeddings, they are stored locally in this file embeddings.json. So if I open this, you can see it's a 4 plus MB file for about 140 chunks that we have. So this is not scalable, and that's why we have vector DB. So we'll move on to that. Uh, so that's why we have vector databases which help us overcome the limitations of JSONs. Now, why would a JSON that we just saw, why will it not work? It will not work because of three primary reasons. First is performance. It in the plain JSON format that we were using it, every time we make a query, it goes through all the chunks and tries to find a match which is the closest. It is seamless when it is 50 or 100 chunks that we saw just now. But if it is 50,000 chunks, it will become extremely slow. And at larger volumes, let's say 500,000 chunks, it becomes unusable. So you will not be able to have AI being used in real time. That's why vector databases overcome this by using different methods of indexing. A couple of them are hierarchical, navigable, small worlds, and inverted file index. We'll not go into depth for either of them, but that's just an easier way of finding and not going through uh, a brute force loop and finding the relevant chunks faster. Second is filtering. Um, if the query requires chunks to be found only from a particular section or a particular part of the database that we have or the files that we have, um, the current embeddings.json file will not allow us to do that filtering. But with vector databases, that can be done. And vector database, like any other database, is an infrastructure component. So if you do something that we just saw, like an embeddings.json hosted somewhere, there's no persistent, you'll have issues with concurrency, backups, replication, and so on. So vector database is a real database which kind of overcomes all of these issues. Next, we will look at the vector databases that are available to us. While there are dozens of them available today, we'll just compare two of them and identify the key differences. So Pinecone is one of the easiest and probably one of the most popular vector databases that are being used. It's like using any other SaaS platform where you have an API key. You can use that to create your vector databases. You can create your indexes and so on. And it is everything else is managed, so you don't have to worry about the infrastructure and so on. On the other hand, you have your PG vector, which is your Postgres vector. So companies which are using Postgres for their applications in general might find it easier to have a PG vector do their chunking, embedding, and using them in the RAG pipeline. Now, one of the major reasons why enterprises would lean towards PG vector is often compliance and the data which they store as embeddings in their own PG vector. uh, it is relatively safe, or they would consider it safe, rather than giving it to a third party like Pinecone. So a lot of enterprises would want to do this. We are not doing it today. We'll look at Pinecone, but yes, that's a major factor for enterprises to consider on where does their data reside. Now we're going to look at how to use Pinecone. So I already have my Pinecone dashboard open here. I've already logged in. I've not created the index. We'll see how that gets created. For this, you'll just need the API key, which I've already taken and added to my project. Uh, I can go back to the database and indexes, and we'll create our first index directly from our Python. So moving on to the Python bit, I asked ChatGPT to kind of give me a code which integrates Python into our existing RAG pipeline. It has already done that, so everything remains the same. Chunking remains the same. The Pinecone setup is something that gets added. So we will uncomment this and run it for the first time because we are creating the embeddings and uploading to the vector database. Everything else remains the same. Let me shut this and we will run this. Okay, we ran into an error. It says something about the wrong file being used. Let me just correct this. Updated it and we can move forward. I will clear this and we will run this again. So the chunking bit is done. We can see an example chunk, and it's just using some specs on which cloud, which region, and how this data is stored. Once this is done, we'll get this message, so we'll just wait for it. Okay, so as you saw, it took about a minute to upload everything to Pinecone, and we can see the entire RAG pipeline is working. So it's getting information from Pinecone and giving us the answers that we were till now doing it, till which we were doing till now with embeddings.json. Now let's go back to the Pinecone dashboard and see if the index is created here. So as you can see, this ClearDesk knowledge index has been created. You can see where it is hosted. The dimension is we have 1536 vectors which represent any chunk. You can add text tags and configure it. We are not getting into it. Um, we'll just look at some of the records. So if you notice, um, you can see some of the records real time. So you know the chunks have been uploaded. And somewhere here you can see the record count, so 147 chunks, which is what we created in our third strategy. So you have a lot of these dashboards and you can use them. We are not spending more time on this. We'll just move on to the next bit. So till now what you've seen is you've done the chunking. We've used a vector DB. So every time now we ask a question, instead of referring to our local file which had the embeddings, it's going to make a call to Pinecone, get the relevant chunks, make a call to the LLM and give us the response. So just to summarize, our vector database is now set up and our pipeline does the same thing that it was doing earlier, where we are giving it a question, it is giving an answer which is grounded in based on the knowledge base provided. Now it also has a real infrastructure, and with the vector database coming in, we can handle any number of chunks, whether it is 50 or 50,000, with the same amount of ease. Now we'll move on to the next bit, which is how do we ensure that there is a conversation memory? So if a user asks how do I export my data, the answer is pretty good. But if the user asks a second question after that, saying I tried that and got a 403 error as mentioned here, the LLM needs to know that their original query was this, and then while doing this, they got this error, right? So that is the conversation memory. If I send this to the LLM directly, saying that I got a 403 error, there's no way any LLM or even a human will not be able to resolve this without knowing the context that the customer was trying to export the data. And that's a memory problem. And it is one of the most common ways in which AI systems fail. So we'll see how to build that. Now, just to see this example, we had already asked um, our LLM, which was trained on the data that we provided, on how to export a project data as CSV. It gave a response. But now if the user or the customer asks a second question saying that they are facing an error while doing it, let's see how the LLM responds. Okay, so it did the chunking again, which is not commented out, but here you can see an error indicates that the user is unauthenticated and so on. It is giving a generic response, irrespective of, it is giving a generic response without knowing what the user is actually trying to do. Um, and it says, if you believe you have access, please let me know and I can escalate it. So the point being, if a user was trying to export and they went through the first step, they already have access. So this statement is not relevant. Um, so this is the issue with storing or having conversation memory, where in our current structure, the first message sent by the user is not saved in memory or in context for the subsequent messages which the user sends. Now let's look at a few ways of or approaches of creating this memory. The first one is where we send the previous messages from the user and the responses from LLM as history with every prompt that is sent out. Uh, the benefit of it is that the model sees everything. So it has the full context and gives appropriate responses. The issue with this is that the token usage grows with every turn because you have new messages getting appended and nothing is getting removed. So long conversations could become very expensive, but this might still be a relevant approach where most of the conversations are short, and the context or reading window approach where you say you will send the past n number of messages in every prompt. So let's say you are going to send five previous messages in every prompt, and the ones before that get dropped. So the benefit of it is that there is some context window which is always maintained. The con of this is that some previously important message gets dropped, and that screws up the response from LLMs. The third approach, which is, let's say, a summary memory, where the previous messages are summarized and then the response or the new message is given along with that previous history to the LLM. It has a few issues as well, wherein you have to make an extra API call to summarize it. And again, in the summary, some important detail might be dropped. So based on the use cases, one of these approaches or a combination of these approaches can be used. One important thing to note at this point is whenever we are building conversation history, especially for enterprise clients, uh, account for having users delete their conversations or a flexibility for users to delete their conversations built from day one to comply with the GDPR. Now to test all the three approaches, I've asked again AI to generate code for all these three approaches, and it has given me an option where I can switch between these three approaches, and we'll see how each of them perform. Uh, in this file, it has given functions for all the three of them on how this memory is created and how it appends data as a conversation, or how does it summarize it. So there's an extra function of summarizing this as well, right? And we are now going to start with the first approach, let's say where we are saying the full history will be sent. And I'm going to run this for the same questions that we had earlier, right? So I'm going to run the first approach. These are the series of questions which the user is asking, and let's see how the responses come out. Okay, so the chunking is still happening, which is fine. We'll just go with it. Uh, Mode is full history. Somebody asked this question on I'm on the enterprise plan with 14 workspaces. This was the answer. The enterprise plan includes volume licensing and multi-workspace management, which is ideal for accounts with multiple and so on. So it's giving some more information. Then somebody is asking, how do I export project data as a CSV? It is giving the answer that we have seen earlier. So in this case, plan limits, and it goes on to mention that this has nothing to do with plans. It is about the allowed number of API requests per minute and so on. So in this example, we are sending the full history and we are getting responses which we were receiving earlier as well. Now let's change the approach, go back and change the approach from full history to a sliding window history, or just a sliding window, right? And let's just see, we'll move on to the next approach, which is the sliding window approach. I've changed this approach here with a window size of 3. And I have modified the questions a little bit to illustrate this example, where in the first few messages, the customer or the user is giving some information about their plan. And towards the 6th, 7th question, when they ask something related to that plan, we'll see if the LLM is able to answer them properly. So now let me run this. The first question is being asked. I'm on enterprise plan with 14 workspaces and 200 users. LLM gives some response. Then it says our account ID is so much. We are based out of this region and I'm trying to export data. It gives response on how to export data. The user says I'm facing this issue. It explains the issue. The customer keeps on asking about I'm the workspace admin, so this should not be a permission issue. And it responds to that. A couple of other questions, but coming down to the last question where the customer asks, does my plan allow 14 workspaces? I'm not sure. So here, if you notice, the response is the documentation does not specify limit on the number of workspaces. However, each new workspace you create will start with a 14-day trial of the Pro plan. After the trial, workspace will automatically move to starter, uh, and so on. So as you notice, the last answer, even though in one of the previous messages, the user or the customer had explained that they are on the enterprise plan, by this question, since that is not a part of the context anymore, the LLM is not able to memorize this. It's not a part of the context, and the answer it gives is not relevant. So this is the second approach, and we saw the limitations. And this was just an illustration, but the actual use cases might be similar. So even with a larger window size, sometimes these issues might still crop up. Even if you have a window size of 10, 15, 20 messages, these issues might still come up. The last approach is the summary approach. Let me just update this here, clear the terminal, and we'll run this where everything that the customer is speaking with the bot, all the context is being stored as a summary and being sent to the LLM in every turn. And we'll see if the last answer is any different from the previous approach. All right, so we've got the last answer. It says the documentation does not specify the limit on the number of workspaces for the enterprise plan. And since you are on the plan, it is likely something. So in this case, in the summary, the LLM was able to maintain that the user who's talking is on the enterprise plan, and the responses were based on top of that. So were based on that. So this is just an illustration of how these three approaches could give you slightly different responses, and you will now start understanding why deciding this approach is important, and you can design your approach based on your use cases. Now that we are getting these responses, our basic RAG is working and we are getting the responses that we want. But that is not going to be enough. In an enterprise application, you would want a few other things as well. Let's say when a response comes in from the LLM, you would want to track whether uh, along with the response, is the customer getting frustrated, or how much confidence does the LLM have on its own response? Does it think it should escalate this chat or this conversation to any support agent who is a human to be able to manage some of the more trickier scenarios? So for this, let's say if I just change the prompt here and I ask it to give a few more details in a JSON format in the response from the LLM. Let's say category of a ticket. You can maybe say this could be about product or process or maybe pricing, billing, user management, right? So these might be the categories that you would want to identify the customer queries for. The sentiment of the customer, whether positive, neutral, negative. Response is the actual response that we are seeing so far. But do you or does the LLM feel that this needs to be escalated and the confidence level on this answer that it's getting? So for now, what we've done is we need all of these to be able to identify whether the message that LLM has given us, should it be shown to the customers or should it not be shown to the customer because confidence is low? Uh, or should it be escalated before sending this response? So all those logic on the UI UX of your application will depend on some of these things also coming along with the response from the LLM. For now, if I'm just asking for these things as a part in the prompt, it may not work always, but let's try it out for once. Let me run this. So we are asking for these fields along with the response in a JSON format. Let's see what the JSON format looks like. So we have the same set of questions. So the first answer, if you notice, came in as a JSON where we have category, sentiment, response, escalate, confidence. This seems to be following the trend. This again seems to be following the trend or the structure that we gave. This one as well. And almost all of them are following this. So this is one of the ways of getting a structured response um, from the LLMs, where you ask for the response in a JSON format. The method that we used here, and surprisingly it has worked, is giving the JSON format in the prompt itself, which, let's say when you have hundreds and thousands of tickets getting uh, generated every day, uh, these formats in this simple JSON prompt may not be adhered to every time. In this case, as every day. So there's a more reliable method, which we will see now. Outputs are important. So you might want to have these parameters in every response for multiple reasons. For example, the category, whether it is a product, process, pricing, billing, user management. If you have these tags, the ticket could be routed to the correct team. If there's a sentiment where it is flagged as negative, uh, maybe it's a frustrated customer and that could be escalated to a human much before the customer kind of leaves without getting their answers. Again, similar something for escalate. It triggers the movement from AI to a human. And confidence. Again, if the confidence is low on the response itself, maybe it will ask to check some other documents or maybe raise it to a human. So you might need all these parameters in every response. And that's why structured outputs are important so that you can process the responses apart from the things or the text that the users see. You can uh, maybe take some business calls, you can change the UI, you can transfer the tickets and so on based on these values. And for this to work, and it forces the LLM to give you one of these values in every response. It can be one of the lists that you have given. In this case, for categories, you have all these values. Um, Sentiment could be these three values. Response, you can mark it as string so that there's no other restriction apart from it being a string. Escalate is a Boolean value, so it will always give you a true or false. And confidence is a float value between 0 to 1. So these are some rules which ensures that the JSON that the LLM responds with always has these values and these validations in place. Now, without enforcing the schema, you might face some of these issues where model outputs as markdown instead of JSON. It adds a few words or prose or omits fields. Um, and this is something where your enterprise application will break. You may not see it when you run it for 5, 10, 50, or 100 times when you are testing it, but with hundreds and thousands of conversations every day, it will most definitely break. So you don't, with this schema in place, you don't need to add complex logic to find these values inside the response. You don't have to look for alternative field names. It will work every time. So that's the benefit of having a structured output. Now again, I've asked ChatGPT to give me the structured output code using Pydantic. So it has imported this library and it has created this class which defines the schema of the responses. And you will notice this class is being sent along with uh, the API call to GPT saying and passing the class called support response. So with this, you will see that all the responses that we get are in the defined format. And just to contrast with what we are seeing currently without this in place, you will see some of these responses where, let's say, the response starts with the word JSON, and you have these three backticks at the beginning, at the end. So if you actually had to process it, you would have to do a lot of cleaning, but we'll clear this out and we will see what the new structured output format gives us. So you'll notice the questions are the same. But now you are getting these values. The JSON is actually being cleaned and you are getting these values. You will always get a very, very consistent output in this format. And this ensures that you can build your business logic on top of it and you can have very well-defined flows on what happens if the sentiment is negative, what happens if the escalate is true, what happens if the confidence is uh, uh, maybe low, what happens if the confidence is high and escalate is true, right? So depending on these combinations, you can actually decide when to transfer to human or when to allow AI to continue responding to the customers. Now with this, we have getting a reliable format which we can use. And with this, we come to the end of this video where we have implemented the RAG pipeline with a vector DB and a chunking strategy which works for us. We have implemented conversation memory using the summary approach. We have a structured data response in place using the Pydantic schema. Now what's next is estimating the cost of running this and whether it is actually better than having humans. So you'll have to identify or determine the cost that you might save by using AI to answer some of the customer queries. And then you'll have to take a call whether to actually move ahead implementing this and putting this into production or not. So that's what we'll see in the next video where we